Hello and welcome back to Techweek TV. We're here in Dunedin today and it's my huge honour to be presenting this session on how new technologies are aiding conservation efforts in Aotearoa. My name is Jake Miller, I'm the co-founder and CEO of Unfiltered, and today I'm joined by two very impressive gentlemen who I'm really excited to learn more about. We have Max Quinn, producer and cameraman at Natural History New Zealand. Thank you so much, Max, for taking the time. And we have Hoane Langsbury from Ngai Tahu, an active kaitiaki here in the region. So thank you so much for coming as well, and I'm so excited to learn more about both of your work, and I know you both have presentations to take us through. So in terms of the format today, we're going to go through the two presentations, then we're going to go into some questions after that. So I'll pass over to Max now to kick us off. Thanks, Max.
All right. Well, I've been in the business for about 50 years, so in fact more than 50 years. So really I'm going to take you back and look over my career and the technological changes that have occurred in that time, and just how we use those technological changes to sort of push the boundaries in natural history filmmaking. So my very first slide, there you are, that's the Natural History New Zealand logo. It's an amazing company and I've worked with them since 1987, and there we are. The title I've called this part of the talk was How Technologies Helped Wildlife Filmmaking, because really of all of these genres, wildlife filmmaking is the one medium that in filmmaking that really does push technology. Virtually every single film that we go out and work on involves some sort of technological challenge for us, and,
yes.
and often we are ahead of the technology, and so we drive the technology in a lot of respects. So what I'm going to do is just play you down some of these amazing images which the Natural History New Zealand have gathered up over the years. I mean, this is a company that has been in existence for over 40 years now. We started way back in 1978, and we started very small and just making those classic Wild South films that people, the older viewers, would remember from way back in the 90s. And I find these films are actually interesting because I think that they are responsible for the conservation ethic that exists in this country today. Because before those Wild South films, those amazing films on kiwis and kakapos and black robins, we'll all remember the Black Robin film, those are the films, nothing existed before them. Then they came along, and now of course we do have this amazing conservation ethic. We're trying to make the country predator free by 2050 and all of those things, and I really do think that those films had a huge influence. And these are just some of those amazing images that this company has produced.
And are some of these your images as well?
Some of those images were mine. I noticed the kingfisher diving into the pool at the very end.
Yes.
That was shot on a Phantom camera at 1,000 frames a second as it dived down to catch a fish.
That's so cool.
Anyway, I'll just move on because I'm going to crank back now 50 years. Believe it or not, that's me threading up a film camera. And the reason why I'm going back, because this was the technology that existed at the time. This is film. It's a mechanical chemical process. It was invented in 1896, I think, and 100 years later it was still going. And it's what has been driving the film business all that time. There were a few minor changes. We went from hand crank cameras to mechanical cameras, sound and colour came along, but basically the same process what was driving images, and then suddenly it all changed.
Yeah.
And well, this here, just before we get on to the big change, of course, this is just a shot I threw in. It's just a beautiful shot of the studio here in Dunedin, taken away back in the 1960s. And this is really how these very first Wild South films would have been compiled on old-fashioned film projectors, poking into video cameras to produce the analog video image that we had at the time. And this is the very first videotape machine arriving in Dunedin. This is interesting because these were big Ampex machines. Just to give you an example, my IT guy at NHNZ told me that one of these machines with an hour-long tape on it would be the equivalent of a 16 gigabyte micro SD card today. So that's what we had to use, and believe it or not, we used to actually take these machines out onto location sometimes. The very first Albatross film, Hoane, which was shot way back in the early 80s, was shot on big video cameras, recording onto big videotape machines.
Wow.
In an outside broadcast van parked up on Tairua Head. So technology has changed. This is just me just scrolling through my career, filming drama productions, and of course the technological change here is that big light on the left. A lot of filmmakers will know about HMI lights, and that was the very first HMI light to be brought into the country, and it really replaced those big brute arcs that you see in those old classic films that they used to make back in Hollywood.
That's fascinating.
For me, the big change in my life was joining the Natural History Unit, and immediately being thrown into the most incredible technical challenge of all, and that was filming a documentary for the Discovery Channel on emperor penguins in Antarctica. And that's me in the front walking along with my camera, and my sound man Don behind, and you notice how everything is so covered up. We had to work in temperatures down to minus 50 degrees, and that was the biggest technical challenge. This is where we lived. These are just like freezer chambers, but inside out. Warm on the inside, but cold on the outside. And just to show you how technology has changed, this was taken in the early 90s. That wooden pole has 2 wires running off it. You might just be able to see them. Those are HF radio aerials. So, you know, that was the way we communicated with the outside world, bouncing signals off the ionosphere in order for people outside to hear us. The sort of things that we wouldn't be able to or allowed to do today, perhaps, because of health and safety. I'm just going to play a little clip down. This is a bit of a making of that, just to give you a sense of the technological innovation that we had to employ. Very simple, basic innovation.
Yes.
Even worse, the intense cold snapped electronic cables like they were twigs. The temperature was minus 50 degrees Celsius, but the crew still had to go to work. No electronic camera could survive these conditions, so a specially designed heater element powered by battery had been fitted to the camera, which was then covered. But the secret of keeping warm in Antarctica is having several layers of clothing, and that also applied to the camera. The colony was an hour's walk downhill, then across sea ice of uncertain thickness. And of course, they were in total darkness.
I knew I was going to have to use lights to film the penguins in the middle of the Antarctic winter, but I didn't know how they were going to react to the light, so I thought I'd set up the light and slowly swing it around onto a small group of juvenile penguins that were some distance from the main colony.
It was enough to depress any wildlife filmmaker. As one, the juveniles moved away beyond the range of the light.
And I thought, you know, God, what's going to happen when I try this out on the main part of the colony with the birds with eggs? It could have been a real disaster. So that was how we had to make a film in the middle of an Antarctic winter. Of course, there's no sun shining down there in the winter, so we had to totally make the film in the dark.
How long did you spend down there?
11 months I was in total, so it's a long time to be away from home. But I had to spend that time down there because emperor penguins only breed in the middle of an Antarctic winter, so there was no other option.
Yeah, wow.
So this next shot here of the Phantom, now this is just another example of us embracing technology that exists at the time. The Phantom Deep Cam ROV was actually designed for oil companies to go and use for their research purposes, but of course natural history filmmakers, we wanted to make a film under the ice of Antarctica, and so we embraced that technology, mounted a camera on it, launched it, and shot our film that way. This is just another example of what you have to go through sometimes to shoot a film. We all look very happy, but we're on a beach in the new millennium sunrise filming it in the Pacific. And the thing about this shot is just the amount of equipment we've got and the number of people in order to drive a small outside broadcast. But you know, this is an example of what we had to do. The materials, the equipment that was available at the time, we just had to get it and adapt it to suit. And if we wanted to shoot a pole camera sequence, filming underwater, then we would take this gear, adapt it ourselves, cable it all up, put it into underwater housings and into waterproof cases, and go off and shoot our underwater filming with a pole camera. This is filmed up in the Arctic, and this is down in the sub-Antarctic, filming using pole cameras once again, filming whales underwater. And of course we found that these pole camera systems are incredibly non-invasive. And really these are systems that really predate the GoPro systems that exist today. And this really is the precursor to a GoPro. We used to have to put these rigs together, and there you can see there's a camera, a recorder, there's the batteries required, there's a timer so the camera will turn on and off, and we could build these units and set them up and sit them next to a bird's nest, or I think this might have been designed for Kakapos filming on Codfish Island, or perhaps sit it next to an albatross on a nest out at Taiaroa Head, and knowing that at certain times of the day when behaviour occurred, the camera would switch on and switch off. And this is the sort of thing that I was able to do. I'm making a film on moose in Fiordland here. Moose in Fiordland that nobody thought existed. And then we sort of recorded this strange looking black creature on our remote camera. It could well have been a moose, we'll never know. This is just something which I think the viewers will be interested in. It's just interesting technology really. Going up into the Arctic and having to film a submarine crashing up through the sea ice, because we're really using it as a metaphor for showing the thickness and how the thickness of the sea ice in the Arctic Ocean has been decreasing over the years. And I could have just gone and filmed
we put a locator beacon at the very spot we want him to surface.
White flat plane, but it was so much more interesting to see a submarine come crashing up through the sea ice.
Have a strobe
that's you in the red?
down in the water.
No, it isn't. I'm behind the camera.
Oh, you're behind the camera. Okay.
We also scrape
It's one of the American guys.
in the ice with a
I
shovel,
like his jacket.
with an arrow
It was very
where
cold
we
that
want
day.
his bow to be. He'll pass close enough at the depth he's coming to, in all likelihood, see that X up above.
It's interesting looking at these.
That's the
This is
spot.
4x3 because of course we hadn't gone to 16:9 when we were shooting these, so we're still in standard definition.
Hawkbill, this is Marvin Gardens. Understand all. Over.
I think this would be one of the most exciting shots that I've ever been involved in.
This was back in Antarctica now.
This is up in the Arctic.
In the Arctic, sorry.
ice cap, yeah. And the submarine is coming up, as you can see, through just about 1 or 2 meters of sea ice.
Wow.
A nuclear submarine, the Hawkbill. And I think it's a great example of the fact that our company will go to the ends of the earth, literally, if they think the shot is important enough
That's amazing.
to film.
And what were you standing on the ice when the submarine came through?
Oh yeah, so we were about 50 meters away from it, and then we were able to go up.
Like, could it crack the whole ice?
Oh yes. Apparently a film crew before us filmed the previous surfacing, and the submarine came up and literally knocked the camera over.
I didn't even know submarines could go through went through the ice.
And
like
this is
that.
interesting
That's
because, of course, those people coming up out of the hatch cover there had been underwater for about 20 days in the submarine doing scientific research. So they were literally in plus 30 degrees coming out into minus 30 degrees. So it's a bit of a shock
The
for
data is
everybody.
slowly coming out, and it has shown remarkable reductions in.
When we're making these films, technology, this is a good example of us having to actually put a rig together in the office first of all before we go out in the field, because some of these rigs are incredibly complicated. This is all the cabling and all the gear we needed for a sequence on filming cubs, tiger cubs giving birth. And we didn't know very much about the situation we were going into. So we had to rig everything up, make sure it was all going, make sure all the cables plugged into the right holes, and then went off to this tiger breeding establishment in Australia. And I'm in the tiger cage here, but the tiger's outside, I hope. And here we are, we've got all the gear inside the tiger cage, all cabled back to a little control room we set up about 30 meters away. And this amazing technology, I was able to film the tigers We had zooming in, zooming out, panning and tilting, all of the things that you need. So that's just a really interesting example of how technology was able to help their particular conservation effort, because of course they had never seen this before, and so we were able to go over there and film it and just see the whole process. Sometimes we lock onto the technology of other companies. Here I am in Antarctica with NIWA have a deep-towed imaging system. They call it DETIS, and this goes down to about 3,000 or 4,000 meters, and you can put your cameras on it inside high-pressure housings, and get these amazing high-quality images on the seafloor of some of these images at 3,000, 4,000 meters down, as I say, incredible pressure involved. And they see these amazing creatures like this little squid that generates its own light, that lives just in the dark. Infrared technology is something we've also had to embrace. Going into jungles, this is something I did just last year in Belize in Central America. Went down there, setting up infrared cameras. If you go near a tree where you know that the jaguars are clawing at the tree, you can set this was actually taken on an infrared A7S camera and a couple of infrared GoPros, and set the cameras rolling and then back off and then come back and have a look at the footage the next day. And if you're very lucky, you get this amazing image of the, of course it was motion pictures, just a frame grab of the jaguars coming in. Scatter a little bit of meat around just to entice them in as well. That's another interesting technological advance in filmmaking. 3D filmmaking is something which we've had to cope with. Although it tends to come and go, 3D filmmaking. Here I am in a studio. We were sent over to Los Angeles to learn basically how to drive these 3D cameras, and when I arrived and saw this huge monster of a camera, I thought to myself, how am I ever going to cope with this in the field? So we basically came back, and we're a pretty innovative bunch. This is Ed Jowett, basically making our own 3D rig using two small HD cameras in the overhead mirror configuration. And then we slowly pieced it together, got it going, and went out into the field and actually used it in the field to shoot a natural history film. Here we are in Fiordland National Park. But we also went right around the United States, in Death Valley here, with the camera in the side-by-side configuration. We've got two eyes, and you can slide the cameras back along those that rod at the bottom to increase the 3D effect. And there's another example where the cameras spread well apart, so that when you're actually looking at over a valley, something that's very wide and very two-dimensional, you can create almost a mock artificial 3D image by spreading the cameras well apart. And of course, here we are in Hawaii, going to film the lava flows in Hawaii at Moana Loa, and of course, all of those cables, every cable's got to go into the right hole. Every cable's got to work, otherwise the whole thing doesn't. So that's just an interesting, and this is a silly shot I put in here where I attempted to do a helicopter shoot with the 3D rig, which wasn't totally successful. I'd have to say that today, you'd probably just shoot these films in 2 dimensions, and they would 3Dize it later on in the computer. Another technical innovation that we've had to embrace is high speed. This is the Phantom, shooting at 1,000 frames a second. You saw some of those high speed shots in those clips earlier on.
So cool.
And of course in the studio, using the Phantom, all those old, I love this shot because of all of those old blondes, those big 2K blondes we had to drag out because they're incandescent lights and they don't strobe, which is the big issue when you're filming with cameras at 1,000 frames a second. Once again, micro and macro filming out in the field. We often take a little set along with us and set it up. This is my filming mate Sid shooting, I think he's just got an A7S there, and doing all our big close-ups as if they actually occur in the natural world. So we often do that. We take the little set along, and it's so much easier for us. He's got the camera on a slider there, and a 100mm macro lens, I think, on the front, and away we go, shooting our big close-ups, like this, for instance. This is just a flash shot I took with my still camera, but this was actually mocked up in a set where the snake, some of you may find it a wee bit distasteful, but the snake devouring the frog.
Wow. That must have been amazing.
It was. GoPro technology, of course, came along, and once again, these cameras were really designed for skateboarders and people strapping them onto their helmets and leaping out of aeroplanes, that sort of thing. But of course, when this technology comes along, filmmakers grab hold of them, and we want to use them for our own benefit.
I use one of my skydiving helmet all the time.
Yeah, that's right. Yeah. But we use them differently. We can now put that last slide you saw, the great big rig that I had for the bird's nest. We can now sort of GoPro in a bird's nest very easily, and it's very non-invasive.
Yeah.
But even today, technology is changing so rapidly that even GoPros are beginning to sort of go out of favour a wee bit. So it's my hope that one day these organisations like who manufacture GoPros and these other small cameras will actually really work on one that's designed specifically for professionals at a very high bit rates that we can use that'll intercut with our footage that we shoot on our master cameras.
Great.
So the next shot is, this is just an example. I think I had a GoPro sitting there in the sand and at a dead fox on a riverbed in Arizona, and the bobcat came up and devoured the. Once again, lens technology, 4K came along, and like a lot of things, the technology was actually these initial 4K cameras. I think anyone who's familiar with the 4K cameras when they first came out, let's face it, they were bricks. They weren't really designed for us to take out onto location at all. They were designed for people shooting feature films and dramas and documentaries, social documentaries perhaps, but really as soon as 4K came out, the natural history filmmakers embraced the technology, and so it forced the manufacturers like Sony and Panasonic and Blackmagic to make cameras that were more suitable for us to take out on location. But lens technology had fallen behind too. We were so used under the old standard, high definition and standard definition days of using very big long lenses, but those lenses were no longer suitable for 4K use.
And what year was this?
So this is only about 3 years ago this was taken.
Okay.
In Arizona here, and that's a big stills lens, just bought from the local camera shop. A 400 to 800mm Sigma lens, but we had to adapt that lens for our own purposes. So there it is hanging on the front of an FS7 with a 2x extender on it as well. So, but now technology has moved on. The manufacturers have caught up, and now they're producing lenses specifically for 4K cameras. And this is a Canon 50 to 1000mm lens with a 1.5x extender in it that we can now take out onto location and shoot beautiful high quality images. The only thing is it's a little heavy, as you can see from that.
Yeah.
But you can see why we need it, because when you're in a location like this where there's not a lot of cover.
And where was this?
This was in Tibet.
Wow.
And there's not a lot of cover, and so the animals are a long, long way away from you, so you need a lens like this to get up close to them.
Yeah. Max, I'm just a little bit conscious of time with the live stream, but this is the most fascinating thing I think I've heard all week. This is unbelievable, and I've got a million questions. I'm just conscious that one
I can sit here and listen to Max all day.
Oh, it's unbelievable. So just while we flick over to Juane's presentation, we need to get these presentations uploaded somewhere online so that the viewers can go through and look through it, because it's just incredible. While we get Juane's presentation uploaded, I've got a couple of questions.
Fire away.
Yeah. What for you? I mean, you've been to so many countries, you've filmed so many amazing things. What sort of has taken your breath away the most personally, do you think, over the years?
Well, I think you saw the photograph of me with the emperor penguins. That was always that was amazing, because it was really my first big natural history documentary, and so I was really sort of blown away by the chance to go and make a film about them. This is a long, long time ago, way before even films like March of the Penguins were made. So we were sort of at cutting edge of technology when we did that film. And the whales was wonderful too.
Wow.
But the chance to get up close to polar bears up in the Arctic was pretty much right up there.
I can imagine.
Actually.
It sounds like you've had the most interesting job on the planet. You're still pretty young. Why did you retire?
Well, I'm not that young. I retired because I'm well over my retirement age now, so
Right.
So it is time for
But
me
you're
to-
still filming? You said
But
you're
I
still...
am still filming, yes.
Yeah.
I'm still filming, and we'll still be doing a
That's
film
amazing.
for the Natural History Unit later this year. So
Right.
yeah, I'm
And
still.
how many countries have you been to?
Well, surprisingly enough, you tend to get pigeonholed in this in this game, and you tend to specialise in polar regions or in the Americas, like I have, or
Got
in
you.
Asia or China. Or in Australia.
Okay.
And I've done a little bit in Europe, but
Yeah.
really I haven't filmed anything in Africa.
Okay.
So there are a lot of parts of the world that I haven't been to.
Yeah, awesome. We'll pass over to Juane now, and I look forward to learning more about kaitiaki and kaitiaki. Thank you so much.
Kia ora koutou, thanks for that. I guess I have a short presentation that'll kind of bring us through from maybe a little bit further back than Max has just talked about.
Yes.
Up to date, but probably just looking at the title Kaitiaki Tech, that really, from my perspective, ties together the last 33 years of the journey that I'm probably only about halfway through, and how that's assisting us as guardians or stewards of the land and the species that are upon it today, and will inform what we do going forward. So you mentioned that I'm of Ngai Tahu descent, and Indigenous people in lots of places, but especially in New Zealand, are early adopters of new technology. So that waka you can see up there was used in the Chatham Islands to travel around between the islands. Whaleboat you can see down there in the bottom, my ancestors eventually started using to travel down to the Titi Islands, but only after the Europeans first arrived here. So during those early days of the Europeans arriving here in those really tall ships, it was important for the whānau that were going out into the ocean and collecting kaimoana and travelling down to the Titi Islands to do that as safely as possible. And when they saw these boats, they thought, oh, well, that's got to be really useful to us, a safer and better way to travel. So they would look around and find one of their daughters and think, oh, which one would I marry off to ensure that we have this technology going forward? But they wouldn't marry them to the captains of the ships, they would marry them to the boat builders or the ship builders, so that technology then became part of their own whakapapa, because the captains were really only good for sailing around and knowing where they're going. They couldn't build them a boat, and that was what was important to them.
Wow.
Our ancestors were really good sailors, or we wouldn't have been here in the first place. So it was that technology. This is the technology that we're at today when we think of moving from hunting whales out here in Otago Harbour to where the whānau joint venture with Ngai Tahu was doing whale watching, and probably the highest tech boats there are in the country, foil-assisted jets, travelling long distances, and also the way they interact with species have changed. So in the past they were sustainably using them and harvesting them. Now they're sustainably taking tourists out to view what's going on and giving them opportunities to learn about the responsibilities that we currently have.
And this is in Kaikoura?
That was Kaikoura,
Okay.
yes, so that was Whale Watch Kaikoura. Just to carry on down that journey, Otago Marae, which is familiar to all of us here in Dunedin, is the only Art Deco marae on the planet, I can probably say. Probably even go as far as say the universe. But the reason we're able to brag about this is the carvings there are made of concrete and plaster. That technology was adopted due to, they were looking at the rebuild around about the time the Second World War broke out, and our tāne or our men went overseas to fight. And timber was also difficult to come by because resources were going into other things. So it was shortly after the Napier earthquake, probably at the pinnacle of Art Deco technology use, and it was adopted and used here on the Otago Peninsula. Another opportunity for new technology to be used by our ancestors, and that was as recently as the early 1940s. But using technology comes with its own pitfalls. You can see here an image of the concrete parts that were originally there and our more recent addition of our wharekai, where we've matched the two recent technologies together. It's seamless in this image here, but only a very short time after this. This here, from the late 80s, was what Microsoft thought was a attention grabber. So no one should be panicking at this point. It's just something I use in here just to remind me I'm going to talk about some issues around failures of technology. And everyone knows that this is a blue screen of death. It'll come up a couple of times through my presentation just to focus me on the bit I'm just about to talk about. Probably older people, probably people like me that may have played around with IT since the mid-80s will understand what the blue screen of death was. I think they kind of still have screens like that these days. Don't mean quite the same thing. Back then you had to figure it out yourself because Microsoft and those were probably training a little behind the rest of us. But adopting technology took about, this piece here took 75 years to fail. So I did get a little bit geeky on this, and the mean time between failure for using concrete carvings on tamatea took 657,000 hours before it failed. And the reason it failed is they took a couple of shortcuts. They went down and got the sand for the aggregate for the carving from the edge of the harbour, full of salt, and so eventually over time it ate through the iron that was used to hold this together. And this will become relevant later on in my kōrero. So around about 82, people that have been playing with technology for some time will recognise this piece of technology. Had a RF output, enabled you to plug it into a television. You kind of got your data into it through a cassette attached to it or something similar, and it ran at about 3.58 megahertz. Just to tie my kaitiaki tech together, I spent some time, well 12 years actually, in the IT industry, and recently before I moved back here to Dunedin and Otago to work for Otago Runanga at the local marae, I was responsible as the computer systems manager at Vic for the campus-wide network. And what we were doing at that time is cell phones were around, they were about a bit smaller than a brick, but not that much smaller. We could plug cable into there and we could run data at 9600 baud. And what that enabled the engineering manager at Vic to do at that time was he carried around a suitcase in his car, and it was almost like James Bond stuff. He could plug his phone into that and he could log into the campus-wide network and see if there was a heat vac system that was failing or there's some other failures there that would inform him whether he had to drive from Eastbourne all the way back into town to fix it, or whether he could just ring someone up and turn it off and fix it in the morning. So we were putting this technology together to manage what I look at as the built environment in the late 90s leading up to Y2K. Wow. About that time I left up there and I came home. These days, and I probably still have that phone in my pocket. You know I do. I haven't updated this slide because about 3 days ago I bought an XS with 256 gigabytes of data on it. There was probably more data on this than there was on the entire campus at the time that we put our building and engineering information management system together. So what I really want to talk about is these guys here, which are the little blue penguins, and these ones specifically are at Pilot's Beach at the end of the Otago Harbour here, in the lee of Pukekura, also known as Taiaroa Head. So what is important to us with these guys was understanding what was going on. So it wasn't unusual to be standing down on the platform, watching these guys come in, 120 of them coming in at the time. I challenge anyone to tell the difference between which one of those penguins is a male and a female when there's 50 of them running past you over 20 or 30 seconds. So we wanted to be able to do that to improve our kaitiaki responsibilities or our husbandry of the birds on the headland. So I was thinking about what I did at Victoria University and thought, why can't we apply the same technology to managing a species in the natural environment? So that's the direction that we're currently heading in, and we've spent the last 18 months doing some development in these areas. So what we have currently done as of a couple of weeks ago, we've put 1,370 RFID tags, so the same tags they put in cats, into the little blue penguins in this colony. You can see little blue dots in here. That's the GPS location of every nest box that's in the colony. So we know where all these guys live. We know which ones are in each nest box and what's going on, because we employ scientists to go around the colony every 3 or 4 days. So a Tuesday and a Friday, scientists is checking up on all these guys. Gives us lots and lots of data. So our next step after this was to move on to automating how we gather this data to improve things. So we searched the planet and we found a company in Australia called Karltech that designed RFID logging systems for tracking sport fish as they swim up and down streams and rivers. So we have adapted this technology to use at Pilot's Beach, and it will inform us 9 o'clock every morning. My scientist and myself receive an email from the system, tells us which penguins have come home the night before. And we have 2 antennae there, so it tells them what direction they're going in. We still have a little bit of work to improve the accuracy, and that's where we're moving to now. This piece of technology cost us about 30K. We've set it up ourselves and have it working for us. So it also comes with some issues, as this little screen here is reminding me, and it comes back to reinforced concrete again. One of the antenna, for some reason, we set on the dune systems where in the past, I'm not going to blame council, but they probably supported it, came in and repaired our dune systems by dumping lots of old rubble from buildings and those sort of things. And there happened to be a 4-foot waratah and a piece of concrete with rusting metal in it sitting right underneath our antenna. And it was just taking all of the energy from our antenna system and taking it straight down into the ground instead of allowing us to count the penguins that were going over it. So last winter we dug out the dunes and removed all the interference and put it all back, and we have a far more accurate system now. Still not giving everything that we need to understand. So when we go through and we tag a penguin, we put a little thing there you can see is actually a mouse ear tag, and it's webbing that informs us that it should have an RFID tag in it, and if it's not being read with our hand scanner, then we will insert another chip in it, because there's about 7% failure in the chips that we're using. But where we've moved to, when the Internet of Things group started up here in Dunedin a year or so back, several of us got together and we talked about how we could improve the data gathering for the project that we're working on, because we now have these 1,300 plus penguins running around with an RFID tag in it. The Pukekura Trust, through the Koroko Karatai whānau and the Peninsula Trust, have committed to this project forever. So over time we expect this will become the Dunedin study for penguins. And what we want to understand from their perspective is initially the whakapapa of the penguins, so the genealogy, who's been breeding with who has what offspring, and how that links together. And so whenever we put a RFID tag into a penguin, we get DNA material and a feather, so we're about to do the DNA sequencing and the work on that so we can understand that whakapapa or genealogy down to the DNA level. But as part of the Karltech work that we put in with the single data logger at the entrance to the reserve, we said, well, we could get more information off this, because it was only telling us who was home and sometimes it was telling us who left. So what we've come up with, our wooden nest boxes we use, is to add additional technology into every single nest box. So we have about 305 nest boxes out there, and we're working on next generation nest box version 3 will actually be full of technology, including a solar panel and a battery and a device that's probably just half the size of a phone sitting on the top of it, that has a laser rangefinder in it, an RFID tag reader, thermostat, light meter, humidity sensors, microphones, and that technology will tell us whether the box has been interfered with by a human, or we've had a big storm event and the boxes have been buried or washed away, which happened in 2017 with those big rains we had here. We had 23 nest boxes we lost under a big sand drift. The laser rangefinder will turn on the RFID tag reader that'll be in the box. That'll tell us who's coming in. It'll also tell us who's going out without us having to go to those boxes all the time. Thermostat and the humidity sensor will tell us that it's a penguin that's in the box, or potentially a cat or some other predator that's gone into the box, because the temperature will be different between it being a mammalian predator and a penguin. Or if the penguin's been in there for some time, we should be at least getting an RFID tag read off it. I've had it suggested to me more recently that, well, maybe if something goes in there and you can tell that it's a predator, the entrance to the box should have a door on it, just automatically drops down and turns into a live capture trap. So we might consider that in the next version, but we think we'll just get the technology in at the moment to tell us what's going on. So that's where we're currently at, and we've been testing that now with the internet group of guys that somehow managed to live in Dunedin but work for companies in Silicon Valley, and they have to return there for a month or so a year and talk to their bosses, and then they come back and live here in this wonderful place that we do and work on little side projects like this one. So this is a mock-up of what the box will look like. We've made a small modification to it, and we'll put the entranceway inside the box. That'll minimise the amount of human interference that goes on, but it'll give us real-time data on every single nest box. We'll know which birds are in which box, and it'll allow us to move to the next stage of questioning that my scientist has, which is around, do the pairs that molt together breed together? That happens to be her interesting question, where my interesting question is, in a fog event, or say last night for instance, where we had 12 penguins come home instead of I think we're at 503 adults that live there, what happened to all the rest of those penguins? Is it the same 7 that come in every night on a foggy night because they have a better way of navigating, or are they the ones that live in the harbour? Having this technology will tell us exactly who's come home and when they've left, but it'll also inform us whether it is the adults that decide, the adult male that decides where they're going to nest, and do they do that within a metre of where they fledged from. There's really cool or interesting things that will help us with our husbandry. We can answer by putting this technology into the boxes themselves. So our research commitment, as I said earlier, is ongoing. It'll go on forever. We are building new relationships with partners locally in Dunedin, but throughout Aotearoa. And we also have groups now starting to come to us, because we just thought we were doing stuff we needed to do to help our work, that actually we're probably doing some stuff here that's groundbreaking in some areas, and we will provide this technology to other community groups and other authorities that have penguins that they need to monitor. So we'll do this under the Internet of Things technology, which will make everything that we develop available on the internet for free, but if someone needs one made, we're quite happy to make them and make a little revenue that can go back into development. So the reason we do this is really for these guys here. There's a little video that I'll let run while we continue to talk. And what the technology tells us is when parents haven't been home to feed their chicks. So we knew this chick was at home by itself, and over a couple of days of being supplementary fed, it could hear our scientists walking up to the nest to feed it, and it would run out and just take food out of her hand. It's the only time we've had this happen in the last couple of years. But for the last 2 years, technology has kept us so well informed that we've been able to identify chicks that need to be supplementary fed. And last year we supplementary fed 64 chicks, of which 63 survived. So without the technology and the high level of monitoring we're doing, we wouldn't be able to do that. So it's probably eaten about 17 fish so far. If you're good at counting, I suggest you keep counting, because this is the greediest penguin chick we've ever seen.
Wow. Guys, thank you so much. I'm so inspired by both of you. Your work is just unbelievable. So, and the passion you both have for what you do is so inspiring, and I know that it's coming across so much on camera. I know the viewers at home will be feeling that as well. We've only got time for one question, which is, you know, it's clear you're both so passionate about the intersection of like the environment and technology. Where do you think the greatest evolution is going to occur in that space over the next 10 years that will help the planet and help the environment? And what's something that you're both following and excited about in that space?
So I'll just touch on that quickly and then I'll
Yeah.
pass over to Max. I'm also involved in predator-free Dunedin, and we had an opportunity to look at the technology that's coming out of zero-invasive predators,
Yep.
and the technology that's going to be there that will enable us to deal with all those things that we've introduced to the
Yeah.
country that are affecting our native species, I think is where we're going to see the advances in technology in the next couple of years.
That's amazing. Thank you so much. Yeah.
Well, as a filmmaker, miniaturisation I think will be
Yeah.
a big advance in,
Yeah.
in technology. Already we're seeing cameras that can be mounted on the backs of penguins' heads and seeing their feeding behaviour, that sort of thing. Drones, of course, are big. Drones are now in Codfish Island are gathering sperm and transporting it down to the hut so they can get the sperm in 2 minutes instead of an hour's walk down the
Wow.
track. So
Wow.
that's how technology is driving
Yeah.
conservation.
Have you been flying many drones?
Oh, I'm not a drone flyer. I don't dare fly a drone. I only crash them at my age.
Yeah, it became my greatest passion recently until I crashed it into a building in LA. So no more drone flying for me. Gentlemen, thank you so much. Such a pleasure. Yeah.
Pleasure to meet
Yeah,
you.
yeah.
Thank you.
Thank you so very much. And thank you so much to the viewers for tuning in from all around the country. Today is the last session I'm going to be hosting here in Dunedin. We've had thousands of viewers tuning in throughout the day, and I just want to say thank you so much for taking the time to tune in and learn from some pretty phenomenal people. I think what today shows is that there's innovation happening everywhere in the country, and it was such an honour to come down to Dunedin and learn about some of it today. So thank you so much to the viewers, thank you so much to the cameraman behind the scenes, to Ali and to the team, and we look forward to seeing you tomorrow for the final day of Techweek TV in Auckland. My co-host Sean will be back today for the next session soon. Thank you so much and see you tomorrow.